Hi everybody, Scott Stanchfield here. Let's talk about RecyclerView and CardView in Android. To start with, just to show you where these things are used, RecyclerView is basically something that'll manage a list of things on the screen. They can show up as kind of a linear list, they can show up as a grid. There's a couple different layouts you can use for them. But the RecyclerView is the guy that manages the entire content. Each of these items, in this particular case, I'm using a card view to represent each item. Notice that it kind of looks a little bit raised around there. Each of those items can be represented by any view you want. You could use the same view for all of them. You could use different views for all. For the examples we're going to do in class, we're just going to use a card view for each of these. But keep in mind, you could have a completely different layout for every single item in the list if you wanted. Part of the heart of the recycler view is model view controller paradigm. And this pattern basically says that you start off with isolating your data in a model. You have a view that represents the data on the screen, and you have a controller which represents the user's interaction. The view is going to ask the model to get some data, and then he's going to display that to the user on the screen. The controller is going to say, hey, the user just did something. They tapped on me, they dragged me, they deleted me, whatever. What do I want to do to the model? So he can update the model. Whenever the model changes, he's going to fire off some notifications using the observer pattern to say, hey, I've changed. Do you want to do anything about it? And then the view and the controller can do whatever updating they need. In the case of the view, he can go back to the model and say, hey, give me data. I'll display it on the screen again. In the case of the controller, he may need to know some information about the scope of something to set the range of a scroll bar, for example, so the user can't scroll farther than the amount of data is available. Note that when the view gets notification, that notification could come at several different granularities. It could be this specific piece of data has changed, in which case the view can say, oh, I'm not displaying it. I don't need to do anything. Or maybe I only need to update that one piece of data on the screen. It could be just a general something has changed and we don't know what it is, in which case the view has to update everything on the screen. Or it could be somewhere in between. It could be a matter of this subtree of data has changed, and then the view can optimize slightly to get that. With a recycler view, recyclerview.adapter is our model. This is the guy who understands the data for the recycler view to use. He also includes the row rendering information. So how do I create data to display for each individual row? The recycler view itself is a combination of a view and controller. So he asks his model for information. So he'll say, hey, give me the next row, give me the next row, give me the next row, and then displays it on the screen. When the user clicks on things, we can then go back to the model and update it. One thing that's really nice about the recycler view is that he can reuse his views. Views are very expensive in Android, so you want to keep as few of them as possible. And what the recycler view can do is, let's say that we had 100,000 elements to display. Maybe only 4 of them can ever be partially displayed on the screen at the same time. So what will happen is, as the user's scrolling, we'll see different parts of different views, and eventually one of the views will go off screen. We can then reuse that as another view. So notice that we have A, B, C, D in this order. Later on, we're down to B, C, D, A. Keep in mind that each of these views that you're reusing may represent any piece of data in the list, depending on how the recycler view reuses them. So don't make any assumptions on what they're actually looking at. For this whole thing to work, we're going to do a nice little sequence diagram here. My favorite diagram of all the wonderful things in UML. Boy, I was going to say URL. Wow. Why was I blanking on UML? So UML in general, I don't have any use for except for a couple diagrams. One of them is this guy, the sequence flow. So we have a recycler view here and the adapter that you're going to define. He starts off by creating a little cache to hold views. He's then going to ask the recycler view adapter, how many rows you got? And we call get item count on the adapter that you define. Once he knows how many rows, he's going to walk through each row, and for each of those rows saying, which view do you want to use? He's going to ask for an item view type from the adapter. Most of the time, you're going to return the same number, probably a 0 every single time. By default, that's what the adapter does. If you want to have a different type of view for different rows, then you can return a different number at that point. So you could say this is version 1 of the row, version 2 of the row, version 3, whatever. For example, if you wanted to have alternating dark background and light background on alternating rows, I don't recommend that. I think it looks really horrible on Android. Some people really like it for some reason, and they're entitled to their opinions. Anyway, when you ask for these different item view types, you could return a 0 for an odd row or a 1 for an even row. So you could just do a mod 2 on it. Once we've got that for the row that we want to display, the recycler view says, do I have one that I can reuse? So is there a view of that specific type that's been created that I can just plug new data in? If so, boom, I'm going to reuse it. If not, so if I couldn't find one, I'm going to go and say create view holder from the adapter. So the adapter is going to create the view that represents that row. We'll then cache that after we're done using it so that we can reuse it later on. To render the view, when we're saying, okay, I need to display something on the screen, he's going to call onBindViewHolder, passing in whatever he got out of his cache or whatever was created. It's then up to the adapter to plug the data in and just fill in the blanks on the screen. The view that you're creating is probably going to be a composite view. It might just be a simple text view, in which case you're just filling in the entire text view, or it could be a composite, like maybe there's an icon and next to it is some text. Your onBind view holder is going to fill in all the different parts of that view for you. Last thing I want to mention here before we get into some code is talking about the concept of swiping and dragging. We can set it up so that at a given view, you can swipe it to one side or the other, and it'll start like showing some little red and a delete icon, for example, to say it's going to be deleted. And then once you swipe it, it gets deleted and the list actually kind of collapses a little bit. This is actually very easy to do. You just have to define a callback that says which type of swipes are allowed. In this particular case, I said only left swipes are allowed. You could also allow dragging to reorder things. In this example, we're doing an order from the database, so I'm not going to allow vertical dragging to reorder. And then you say what to do when those swipes actually happen. You can also have additional thing to draw this little red and the icon in there, which is kind of a nice little extra for the user.